Okay, good morning, everyone, and welcome to this webinar on the STEAM system problems, causes, and solutions presented by Spirax-Sarco. We will be having Nick Wisby, Anthony, Anthony the producer, and also Cornelius will be joining us in the background. And just to start off, I will start off with, of course, Nick will be presenting we'll be doing our presentation. And of course, many of you already know that Nick is our technical support engineer with a rich background in engineering industry, over 2 decades experience, technical application, electrical engineering, controls, instrumentation, and STEAM. He's been part of Spirax for about 7 years now, 8 years, and now he's based in Spirax-Sarco, East Africa, here in Nairobi. So before we can proceed on, and we will start off with a bit of housekeeping. This session will be about 1.5 hours, presented by Nick, with the last about 15 minutes having a Q&A. Your microphone will be muted throughout the session, and if you have a question, you can submit the question through the Q&A panel or function, which can be found on the webinar dashboard. We can go next. So if you see on the right hand, you'll be able to see where you'll be able to type in your question. Just type in your question in the compose box and click send. But if you don't want, if you want to post it anonymously, please select as anonymous, post as anonymous, and click send it so that we can be able to see it. I will be able to view your question, and I will be able to post it so that the rest can be able to see, and we will be answering as we continue. So question will only be seen by the hosts. It may not. It may not be possible for us to answer every question during the Q&A session, but of course we will reach out to you to ensure that all of your questions are answered. So I would advise you to please fill in the feedback form after the webinar so that you can be able to get a hold to you and give you back your answers. Okay, so I'll hand over to Nick, and he will continue with the presentation, the rest of the presentation. Over to you, Nick.
Thank you very much, Anthony, and welcome everyone to our, I think it's our 6th installment of webinar. As you can see, the agenda is up on the screen. As always, we will start with who is Spirax-Sarco, just to give you a familiarity with our brands and our product range and where we can support you. We will then talk about steam quality, the different grades, where they're used, corrosion in your system, as that is the enemy. We want to prevent that as much as possible. Stool, so where you can improve efficiencies by heat transfer, by removing condensate quickly. Flash steam losses, so an area where you can save energy, therefore save financial cost per year. Poor heat transfer, reasons for it, and water hammer in a system. So firstly, who is Spirax-Sarco? So we were first founded in 1888 by Sanders and Reinders under the name Sanders, Reinders and Co., which was later formed and shortened to make Sarco. In 1932, we started manufacturing in the UK under the brand name Spirax. So this gave us the company name of Spirax-Sarco. So we've been around for a while. We have 145 operating companies in 180 plus local sales offices. 55 countries are served by distributors. And we have, I think it's a bit higher than this now. I think we have closer to 11,000 employees worldwide. And again, I think it's a bit higher than the figure shown. I think it's around 3,000 or 4,000 local service engineers. We have 29 manufacturing sites across 4 continents, and our global HQ is in a place called Cheltenham, which is the southwest of the UK, and 59 training centres. Underneath the Spirax-Sarco group brand, we have companies such as Gestra, which many of you will be familiar with. Spirax-Sarco, where we work, falls under the same Steam Specialties brand. We have Chromolux and Thermolux for our electrical thermal solutions, such as heat tracing, electrical boilers. Watson-Marlow, which is more for peristatic pumps, pump technologies. Again, we were founded in 1888, and we are a FTSE 100 company, which means we are part of the top 100 companies to trade in the UK, and a turnover of about £1.4 billion per year, and a range of 30,000 products with a global footprint. Some of the services we offer, some of these are depending on the area you're in. So condensate and heat recovery on our products, clean steam, humidification, heat transfer solutions, so such as heat exchangers, pipeline ancillaries, so separators, trap sets, those kind of things. Compressed air services. We also offer in service, again, depending on your area, 24-hour priorities, health and safety training, quality steam testing, water treatment and chemicals. And we actually operate boilers. So the picture on your screen is a boiler that we have on one of our sites in the UK. We train people on it, we open it, we service it, we run it. So we have practical knowledge of the products we sell. So common problems, causes and solutions. We'll start with steam quality. So as you can see, there is 4 main types of steam quality. So starting from the bottom is what most of you will see. So for HVAC, laundries, pulp and paper, petrochemicals, you'll see plant steam. This is your typical steam system with no filtration, carbon steel pipes, SG or cast iron materials. Then we move to filtered steam, which we also call culinary steam. This is for the food and beverage process. Any of you that work for the breweries or in the food industry will be familiar with our filter units, which then afterwards, all the pipework will then change to stainless steel so that you can remove any corrosion, erosion. Then clean steam, which is for hospitals, cosmetics, life sciences, food and beverages again, more for where steam is in contact with a product, because steam is then an ingredient of those products. And pharmaceutical, so ultra pure, ultra clean steam systems, high filtration, demineralized water systems. So causes of steam contamination. So as you can see on the screen, we have a kind of a mini whole system. It starts when you enter your raw water into your softeners. So you get particulates there from the tap water. It could be parts from their line. It could be salts. It could be various different minerals. So that we try to filter those out. You then get chemicals that you have to dose into your feed tank. Again, so this is a contaminant into the water. Boiler, steam inherently is clean, but if you get carryover, so you get moisture, water carry down the line, condensate, it will carry those chemicals and any particulates that are there, and that runs down your main line. You then have pipe scale, so from the turning on, turning off of a steam system, the condensing of water, from the having the salts and the carryover, you'll then get contaminant pipe scale and corrosion as well. So when these steam systems cool down, they combine with oxygen, creating carbonic acid, which will corrode your pipes. And there is always the chance of cross-contamination. So whatever process you are running, if you have any leaking seals or any areas where your process can leak into the steam, you'll get contamination carry back to your feed tank. So industrial users of steam. So CIP, as you can see, tends to be for the pharmaceutical or biotech, brewing, healthcare, brewing, food, cosmetics. Clean steam rooms, so with humidification, pharmaceutical and healthcare, and electronics, because you want to keep dust away. Sterilizers, autoclaves, again, pharmaceutical and healthcare. I'm not going to go through the entire list because you can see it, but I'm picking out the ones that you may be most familiar with. And cooking, for instance, the food industry. Or steam quality, so that equals wet, steam, scale, rust, particulates in your system. So problem can be process contamination, insulation at heat transfer, extended process times. So the wetter your steam, the less enthalpy it will carry, the less heat or energy it will transfer into your product or your process. And increased resistance, so problems in process, problems with getting steam down to the lines, problems with overcooking or undercooking. Pumps, increased maintenance costs because of strainers, and increased maintenance from erosion and corrosion. So likely causes, it's poor control of steam boiler. So we spoke of, or we touched upon, the carryover. Poor raw water quality. The more contaminants you have in your raw water making its way to its feed water, the more contaminants you can potentially have in your steam system. Poor water treatment, so faulty RO, so reverse osmosis or softener systems. And wet steam, so from carryover or a buildup of condensate from improper trapping. At this point, do we have any questions? Anthony, is there
No
anything?
question right now, so we can proceed.
No, so guys, keep those questions coming in. It's what we do these webinars for. We love answering your questions. So solutions when it comes to poor steam quality. So install or upgrade of system, maintain separators to reduce heat losses, so you're drying your steam. Improve insulation, so we can lose a lot of energy, a lot of heat from atmospheric losses. Strainer orientations, so we will touch upon that later, but the orientation of your strainer in a steam line will be different to a condensate line, and there is a reason behind it. Upgrade of boiler blowdown and level, so the better blowdown control, better level control that you have, the more efficient your system can be. And we can also, which we will cover later, recover some of that heat too. Controls, so fitting steam filters where you need cleaner steam, an upgrade to clean steam, so with a change of pipe works and so on. The corrosion, so where do we see corrosion? What does it affect? Corroding for failing steam traps and internals. So if you see traps failing open from corrosion, from damage, from water hammer, you're going to see losses. Corrosion in steam trap bodies, so they are SG iron, most of them, or cast iron. It's a little bit more open to carbonic acid. So bodies will see pinholes, pin leaks, slowly corrode away, again giving you losses. Corrosion in condensate return pipes. So if many of you will see pinholes in joins, bends, where you have condensate running, that will give you a loss. Increasing water treatment, chemical costs. So the more feed water you're needing to pump into your system, more raw water, more chemicals and treatments you're going to need, so it increases the cost. And increased blowdown, because you see more particulates, you're going to have to blow down your system more to bring them back into level. Causes, as we covered a little bit, poor air venting, excessive stop and start of boiler, so where boilers potentially run for shorter shifts. Again, on that, it can be running boilers on lower pressures than are rated on the plates. Excessive stop-start processes, so if you have a non-continuous process which may only run, say, once or twice a day. You will get a build-up of condensate behind the control equipment. Poor water treatment, again, from carryover, bringing those chemicals into your steam system. And poor boiler control, blowdown control. So if you're not blowing down enough, or you're seeing an increase in your levels of TDS and your particulates in your boiler, you need to blow down more to be able to clean it. So solutions is to fit and repair air vents, to select appropriate steam trap types. So we have different steam traps for different uses in the industry, not just in Spirax. And check water treatment regime. Make sure that you're only dosing what you need to. You're not overdosing your steam system. And upgrade of boiler controls. So for instance, on-off pump controls can be changed to modulating, so there's less thermal shock on your boiler. TDS controls, so automatic TDS blowdown, automatic blowdown on your boiler. These are things that we can change to increase efficiency. Is there any questions before I move on?
Yes, there's one question. The question is, how could you identify the corrosion on boilers?
So it is relatively easy. You'll see when you inspect your traps on your routine inspections, you'll see more particulates than you have seen before in the strainers. You'll see the inside of a pipe become thinner. Inspection of a boiler, for instance, one of the inspections you should do is the wall thickness of the boiler to tell the lifetime left on that boiler. That will also highlight any excessive corrosion or erosion inside there. Same on a steam pipe. So the wall thickness tests on pipes is essential to be able to maintain the pressure or the maximum allowable pressure in the system. Again, if you start seeing that traps are needed to be maintained more often, that's could be an indication that there's more erosion happening, which could be an indicator of carryover. And wetter steam as well will be, if you're not seeing the heat transfer you expect, there is the potential that you're getting carryover or at least a build-up condensate. Condensate is the enemy in a steam pipe because it acts as a barrier to heat. So it could be an indication you've got failing traps. Another indication of failing traps would be excessive flash steam from risers leading out of the building or the top of the feed tank. So all of these will indicate there's a challenge in your steam system. As soon as you get leaks, if they're not dealt with, they will cause more erosion and corrosion. Hopefully that answers your question. Anything else?
No more questions. We can proceed. Thank you.
Okay. So we'll move on to stool. So what is stool? How can we prevent it and how can we cure it? So problems, the things that you may start seeing on site, that's an indication of stool, is erratic temperature control. So your process times are taking longer to heat up. Spoilage, so for instance, if we talk about the dairy industry, when it comes to products, if they do not achieve temperature for pasteurization, most of the time that product has to be wasted. And then there's investigations on why that was wasted. Energy inefficiency. So the more stool, the more condensate you have in your system, the less energy efficient it's becoming, which means it's becoming more expensive to run. Hunting of control valves is a major indication. So if you see a control valve opening and closing, moving around instead of being very steady, that's an indication that you have a challenge there with either stool or condensate. Steam leakage, loss, inefficiency. So again, as we covered with leaking traps and product spoilage. Corrosive condensate, so excessive maintenance, as we touched upon earlier. If you're seeing your traps are needing to be repaired more often, that you're seeing more leaking traps, more traps failing open or closed. Pipework corrosion, as we spoke about before in the previous question. Rust, cross-contamination, so in your strainers, if you're starting to see process media in your strainers, or you're seeing excessive rust particulates, and increased chemical dosage costs, increased blowdown because you have more particulates, and increased maintenance, downtime, and replacement costs on heat exchangers. So as it says here, causes insufficient differential pressures, so the steam isn't being pulled through the system properly. Increased back pressure on trap, so you're unable to clear as much condensate as you require, leading to the filling of coils, or for heat transfer processes like a heat exchanger. Reduced heat demand by process, so effectively that's a little misleading, that statement, but it's effectively taking longer to heat up your process. So an example of stool here, we've taken an air handling unit here, but this could be a heat exchanger, it could be a coil, it could be anything. So as you can see, you have your separator, your isolation valve and control valve at the top left hand of the picture. Hopefully you can see my laser. And at this particular case, we've got 4 bar, and that's 152 degrees. So as steam enters the system, it comes into the coils, air passes through, picks up the transfer of heat through the enthalpy, and then it turns to condensate and is removed by the traps and sent back to the system. So here, when demand for heating lowers, you'll see the control valve starts to close. So you get a pressure drop here. This then can be lower than the pressure that's in your traps, which increases the buildup of condensate in the coil, which then decreases the efficiency of those coils. And that's what we call stall. So how we could remove that. So sorry, I just touch back on that because I feel like I should just clear something. The reason why you're getting stall here is this control valve closing. You have the collapsing of steam along this line here, which creates a vacuum. So the pressure across the trap becomes close to 0 on this side. You have a back pressure in your condensate line, say it's around 2 or 3 bar. So the trap can no longer pass condensate into the trap and through the condensate line. That's what gives you stall conditions, mostly caused by the closing of this control valve, or not enough distance between, so not enough drop between your trap and your coils. So how we can clear that? We can use APT, so an automatic pump solution. So what this does is it reduces the back pressure on the trap. You fit vacuum breakers after the control valves to allow air in, so you're not pulling a vacuum. Although we would recommend other solutions before that. Pump the condensate. So as you can see here, we have the APT that I just said, the automatic pump unit. This is a larger vessel, so it's an MFP for larger flow rates. So it's still a pump trap with a vessel here, so a receiver to collect condensate. And here we have the electrical solutions that many of you will have on site. So an electrical pump, a receiver that receives the condensate and pumps it back to your system. Anyone have any questions over stall?
We do have a couple of questions. They may not be on stall, but nonetheless, some questions there. The first question is, I have a Vapomat coil boiler that's 600 kgs per hour that is building up scale more frequently. The feed water is tested and it is soft water. What could be the cause of the blockage?
So building up scale, so you've got salts that are adding into there. So the water softness could be the issue there. You're finding that you're getting salt added into your system. Could be the lack of blowdown or lack of TDS control. If you don't have any TDS, which many boilers in East Africa don't, it's manual rather than sensors. It means that the particulates in your boiler are allowed to build up. So we would recommend that the TDS level is kept lower than 3,500 particulates, ppm, parts per million. Doing that manually testing would give more particulates in your boiler and therefore cause more more scale or potentially cause more scale. Hopefully that answers that question.
Yeah.
If there's any more information you want on any of these questions, please feel free to add another question or to message us directly.
Okay. So if we go to the next question is, what are the major cause of ball float steam trap? Think is a ball float steam trap failure. Our steam trap has failed with less than 1 year, while it's expected to serve minimum 5 years. It is spiral made. I believe it's Spirax made. And I believe it's the same question. We found the spring was very corroded and lose its elastic properties.
So there's a few solutions, or a few causes there. So one of them, we can visit site and be more specific. So these are a little bit general. It sounds like the buildup of carbonic acid in your system. So you have air entering your steam system. This could be during shutdown, so that your gaskets or air vents or vacuum breakers are allowing air into the system, so the forming of carbonic acid, and that's sitting there in the traps until the system is fired up properly. It could be water hammer, it could be causing damage to the ball, so therefore it's no longer effective, or it could be particulates in the steam trap, which is getting caught on the valve seats, so that they're no longer closing properly. With the corrosion, the excessive corrosion, I would say that would be more likely to be either the carryover of chemicals or the formation of carbonic acid in your system.
Yeah, and I think the same person could be, because it says how excessive stop and starts increase the formation of corrosion.
Yeah, so as the steam system cools down, the steam collapses, which creates a vacuum. The air has to enter that system to become equal to atmosphere somewhere, usually through a vacuum breaker, or it can be more often than not on the perishing of a gasket between flanges. So as you start and stop your system, because you're cycling from steam to vacuum more often, you're introducing the possibility of carbonic acid by condensate and oxygen mixing more often. So a hot steam system removes air, a cold steam system introduces it. So the more you start and stop, it be it process or boiler itself, the more potential there is to introduce those issues. Hopefully that answers that.
Yeah, thank you. I think we've completed all the questions.
I don't know if there's anything I've missed, Anthony, that you would like to add to those as well.
Yes, for example, for the boiler that has cause of the blockages, I do agree. A TBS regime could we need to investigate if you're doing a correct blowdown regime to your boiler, and also we need to. I would advise you do an analysis of the soft water, because you can have the water also which is softened, but it could have things like silica or maybe other dissolved minerals that cannot be removed by just softening of the water. So we need to do an analysis to check, do a complete water analysis to check what exactly is in that water that you're introducing to the boiler. Yeah.
Many systems will use RO after their softeners, and it's for that very reason, so they can capture more particulates. If you do have RO and you're still seeing that issue, I would suggest there's a challenge or a problem in your RO plant as well.
Yes. Well, the second person who mentioned about the steam trap, I think if one of our engineers can come to visit your site, would like to see what exactly could be the kind of cause, because indeed the ball flow steam trap, Spirax-Sarco, should not last only 1 year. So definitely there is something that is wrong with your system that we need to investigate and assist on how to stop it. yeah, or to give solutions to. So I believe I think he's asked another question is how often we suggest I blow down my Vapomat boiler if I run it for 12 hours a day. At the moment, we only do one blow down after a day's work.
So it's about right. I believe the recommendations are that you blow down either once a shift or once a day. But again, TDS is critical there because TDS is a separate blowdown from the main boiler blowdown. That kind of bleeds the boiler continuously almost, so it keeps the particulates down. If you're relying solely on blowdown for a boiler, that's a long period. So once per 12-hour shift, that's a long period of fresh water, water, be it from the feed tank or from tap water, entering the boiler without any control. TDS blowdown has to work alongside boiler blowdown because of the infrequency that we do boiler blowdown. I don't know what the local legislation, I believe it's the same as Europe, Anthony, isn't it? It's one blowdown per shift or per day.
Yes.
Yeah.
The same.
So how we calculate the blowdown, the amount you should blow down. So you have between your first low level and your second low level, so your low and your low, the volume of water between those two sensors is how much you should be blowing down per blowdown. So if you have a level difference of say 100 liters, you should be blowing down 100 liters each shift. So that's each shift or each day. So it could be that your blowdown isn't long enough as well. I don't know if you want to add to that, Anthony.
I think we've answered it quite well. Also, there is another question. What is a recommended frequency to change steam traps, safety valves, etc. in a steam line?
So maintenance should be, so when we talk about inspection and service, we talk about them as two different items. So your steam system should be inspected, depending on your use, every 6 to 12 months. Now, that doesn't mean replacement. That just means you want to know what's happening in your steam system. For a trap, we would suggest on a healthy system, so please bear that in mind, that maintenance on a steam trap should be every 2 to 3 years. However, if you're seeing more corrosion, erosion, those times will shorten, and they can shorten dramatically. There's other factors such as insulation as well, and so on, proper control. With a steam trap, mechanical traps, yeah, going back to the previous question of the traps are only lasting a year, we would expect to see in a healthy system those traps last 2 to 3 years depending on use. So when it comes to inspection and service routines, inspection should be every 6 to 12 months. Service should be every 2 to 3 years. So I think that's probably right. Again, those times can be dramatically shortened by an unhealthy steam system. I don't know if there's anything you'd like to add there, Anthony.
No, I think that's well put. We do also have a couple of other questions. Maybe we can proceed there.
Yeah.
And the next one is, how do you identify the amount of energy loss in the blowdown?
So you can calculate that via knowing how much blowdown you've got. We have various calculators on our system and formulas. They're not in this slideshow, but if you fill in the form afterwards and include your contact details, we can certainly make them available to you. There's several different ways. They're without showing the formulas, they're difficult to explain. So it's probably a question that is offline.
Okay. Yes, but yes, you can actually calculate how much energy you are losing from a blowdown system. So just fill in the forms, and then we'll be able to give you the calculators for that, or even guide you on how to do the calculations.
It's also, I'd just like to add, it's also free for us to come and inspect your system. So there's not a cost to you. If you think that you want what we call a steam system audit from one of our engineers, it's just a case of calling us, no matter where you are in the world, and we will come out and see you. The initial inspection, so it's a visual inspection, but we can tell a lot by visual inspections, such as leaks and potential problematic areas. It won't cost you anything, so please get in contact with us.
Okay. So the other question is RO system the only way and best way to solve this? RO systems are waste a lot of water. We are based in Namibia, and at the moment we are going through a drought.
So, yeah, a very good question, especially given the region we're in. There is better ways than RO, but they always come with a cost. So you can have a steam system, a sealed steam system, which uses demineralized water, deionized water. Again, that comes with extra costs because it's the materials required, the ability to be able to seal that system. So I'm thinking things like clean steam generators. It depends on your process. If process steam, plant steam is all you require, then adding the other equipment, unless you see significant saving in water, is going to be more expensive than you require. But again, if you've got a justification because you have either pharmaceutical industry or you're in the food and beverage industry, there is the argument to be made that steam is then becoming an ingredient in the products you're selling. So if you're cooking via steam injection, for instance, steam is an ingredient. It's entering the product. So there is the strong argument for the use of clean steam, so therefore clean steam generators. So I know that kind of goes on a slight tangent, but that's a different system which allows you to use less water because it's sealed to a certain degree. Again, wherever you see steam come into contact with product, you're going to see loss because you can't recover that condensate. RO systems, again, yeah, like you said, they come with their own inherent problems. They're not completely efficient, but they on the market at the moment, when you're very much dependent on the quality of the water you're receiving, are the best solution to remove those particulates. So although it costs you money on your RO, it saves you money on your steam system. Anything you want to add there, Anthony?
Yes. So in a nutshell, what I would advise is try as much as possible to make sure all the condensate comes back, to the boiler. If you return, the more condensate you return, then the less requirement of the makeup water where you have to do the RO etc. So that will help. That can help you. So ensure that you have as maximum possible. Avoid losses. Maybe somebody opening condensate to pour because of stall. Try as much as possible to returning all the condensate back to the system. Also, you can try to change your chemical dosing, or let's say the water treatment program. For example, and this would be more suitable with if you have reputable service providers, water chemical providers who can help give you things like a bit of scale inhibitors, to your water that can help reduce the amount of scaling that occurs to your boiler. So there's some chemicals that you can add in correct proportions. That is a water specialist will have to do that for you, and then you can be able to treat your makeup water a bit better. So yeah, we advise you to go there. Yeah.
Another thing we can share as well. So if you fill in the form and give your contact details, there is a very simple formula that we can supply that allows you to calculate how much condensate you're returning by using the temperature of the feed tank. So if you have a temperature, if you have a tank that's returning, say, I'm using this from an example I worked on this week, say 41 degrees in your feed tank, it means that you're returning roughly about 30% of your condensate. So we would expect to see your feed tank, an open to atmosphere feed tank, at around 85 degrees, because that will that one is an indication of how much water you're recovering, but also it protects against the inefficient use of your fuel for your steam boiler. The hotter the condensate you can return, the less thermal shock you give to your boiler, the shorter the re-steam times are to your boiler. So there's many reasons to return as much condensate as possible. One of which is water recovery, so that you use less water, but it's also energy. So again, like I said, if you fill in the form and give your contact details, we're more than willing to share that formula, which will allow you to see how much of your condensate you're actually returning. Is there any other questions?
No other question at the moment, so we can proceed. Thank you.
Okay. So flash steam loss. Again, thank you guys for your questions. We love these questions coming in. So flash steam losses. So as you can see here, we have an example of a condensate pipe. So the condensate pipe here in this particular case is 100 kilograms an hour at 7 bar, which means it has about 13% flash steam, and which accounts for 99.6% of the volume. 87 kilograms of condensate, which only counts for 0.4% of the total volume in your pipe. So the reason we show this example is we think of condensate being a liquid. It's mostly steam, and that's losses that you see coming down from the differential pressure. So the changing of pressure from your steam system to condensate line, flashing off, causing flash steam in your pipe. So we refer to this as a biphase flow, which just means it's steam and condensate in that line. So flash steam losses, the problems. So increased raw water consumption. So if you take the picture in the bottom left-hand corner here, this is an example that will give you an indication you're losing a lot of steam. So we will see some of this normally anyway. If you have an open to atmosphere tank, you will always see flash off, but it's trying to minimize that loss. Increased chemical consumption, as Anthony spoke about earlier as well, and as we covered. So the more raw water you're having to add to your system, the more chemicals you're having to use. Increased energy consumption, we covered earlier, and increased CO2 penalties. So that's probably not so relevant for this part of the world where we don't have the CO2 penalties, but I imagine over the next 10 years we will start seeing charges for the amount of CO2 you're releasing. Decreased condensate return. So if you're flashing off your steam and your condensate, you're losing energy, but you're also losing water. Decreased water feed tank temperature. So as we said before, the temperature is lowering in the tank because your condensate isn't returning. And a lot of our customers a lot of you in your businesses will find that, especially if you're near residential areas, most people in the area believe this to be smoke, not steam. So you'll see an increase in complaints. So causes. So failed steam traps is another example of where you can start to see flash steam loss. So on average, I only have the figures in dollars, but leaking failed open float trap, for instance, will lose around 12 kilograms an hour. That translates to roughly about $52,000 a year in lost revenue, more money that you're requiring. So if you times that up on the traps, it's obviously that's based on more of a European market, European costs, but we can also calculate these losses for you. So if you get in touch with us and we come see your system, we inspect your traps, we can tell you how much money you're losing just from your failed traps. Poor trap selection. So if you're using a thermodynamic trap instead of a float trap where you're at the end of process, it could be that it's not clearing enough condensate, so that it's allowing condensate to build up, which is affecting the rest of the system. So you're transferring less heat to your process. You're having a buildup of water hammer, all those kind of things. Poor trap sizing. So again, if it's not large enough to cope with the load that is required, you will see more condensate in your steam system. And failed condensate pumps. So if that's mechanical or electrical, it's not able to clear the condensate from the steam system. Again, you will see the challenges of flash off there, loss of energy there, more condensate in your system, and incorrect sizing of condensate receivers. So if you have a receiver which is undersized and is constantly draining water through the overflow to drain, you're seeing a loss there, and because of the pressure differential there, you'll see flash steam too. So solutions. So again, as I mentioned here, we can do we and other companies, but Spirax, so I talk from our point of view, can do a steam trap audit. So we can tell you if your traps have failed open, failed closed. Steam trap monitoring, so you can monitor these traps yourselves. The moment you have a fault or a challenge in your system, it can tell you, and then you can do the relevant servicing. Replace with thermostatic steam traps. So again, that's more for main lines, and use flash steam recovery. So this item here on the side here, you would put into your condensate system. It's designed to recapture the flash steam from the differential pressure and take that to a process that you can use it. So before we move on to the next section, is there any more questions?
Yes. The first question is, from the boiler water sample we've observed that the water looks like a brownish color. What could be the reason? For information, we have a ROS system for water treatment and softener for the boiler.
It sounds like contamination coming back from your condensate, potentially. Added erosion, corrosion. So the brown color, I would suggest, is probably rust that's come down from the pipes. The TDS should clear that. Sounds potentially like you don't have TDS blowdown separate from your blowdown. These will alleviate the issue, but they won't get rid of it. So it sounds like carryover erosion, corrosion is making its way back into your condensate system and then returning to your feed tank and therefore into your boiler. Anthony, I don't know if there's anything you want to add there.
That's well put. So I'll go to the question. The next question is, how can we quantify the loss of energy in the flash system?
So if you're talking about flash steam, you're losing. So if you know your incoming pressure, then the pressure downstream. So say we're going into a condensate recovery unit, which is then normally at atmospheric pressure. So you know it's that pressure, atmospheric pressure there. You have a steam line or a condensate line, which is discharging into there at 3 bar. You know the differential pressure there, so you can calculate the flash off, therefore the energy lost in your system. Again, we have calculators and formulas for this, which aren't in this slideshow. But if you would like more information, please fill in the form at the end, and we can share those. We can come to site, we can explain them, and we can highlight any areas that we feel you are losing energy for. So we're here for your benefit. Use us as much as you can. There is many of our services that are free, so make full use of them. Anything you want to add, Anthony?
Not really, as well. Maybe I can also go to the next question is, what's the best practice in relation to checking the effectiveness of steam traps to avoid loss of steam through failed steam traps?
So there's a few ways you can do it. So we'll start at the cheapest, the easiest. So if you have a sight glass, excuse me, sorry, in your condensate system, You can see if you have condensate passing through your line instead of steam. So that can be an indication your trap is working correctly. If you see nothing, you can tell that the trap is failed closed. Temperature is another one. So by checking the temperature of the trap, tying the temperature up to the pressure of the line, you can tell whether the trap is working properly. So when we speak of, say, 180 degree steam system, it's not completely steam. So at 180 degrees, you can have both water and steam. So the trap should be at the corresponding temperature for your line. If it's hotter, then you can so steam temperature, you can tell it gives you an indication it's leaking. If it's colder than your condensate system, you can tell it's probably failed closed. Then on top of that, we have monitoring systems, which you can listen to the sounds. So there's different sounds on a trap if it's working correctly to if it's failed. We can monitor the sounds. You can monitor the sounds. It's a little bit difficult at times because you need to know what you're listening to. Above that, we have water logging sensors. So sensors that will tell you if it's seeing condensate or seeing steam. And then you have various different systems on top of that, which use various different methods and increase costs. Simplest, sight glass. Yeah, sight glass will never fail, not unless the glass cracks. So, but they're pretty robust. It's the simplest and the quickest way to tell if your trap is failing. And then, again, depending on your solution, depending on the visibility of your steam traps, because these may be 5-6 meters in the air. There is increasingly costly systems to be able to check. Anything you want to add there, Anthony?
Yes, yeah, there are various ways of monitoring steam traps, and the easiest actually will be the sight glass, but we do also have electronic ways of measuring, of checking the steam traps. And actually this now comes to the next question is, what's the best instruments for steam trap audit?
So you're probably better placed to answer this because you look after the service team and know the equipment they use.
Well, for audit, we do use two major systems. The first one is the ultrasonic way. We do have an ultrasonic, a smart ultrasonic gadget that checks if the steam trap is leaking or not, or operating correctly using ultrasonic, because all steam traps, they generate noise when condensate and also live steam passes across them. And if you can be able to know what you're listening to, you can actually be able to identify if a steam trap has failed. So for us, we use it's a computer-based and a smart-based electronic ultrasonic sensor that checks all the steam traps, and also it can be able to calculate the energy losses in terms of a steam trap. We can be able to know how much, by how much in terms of kgs is a steam trap leaking. Also, the other one is we do have an infrared gun where we can be able to check and take either videos or a photograph of the thermal imaging of that particular steam trap. So those are the two major ones that we use for audit purposes, where our service team comes to your site and they use those equipment.
Yeah, so on the high end of that as well, we also offer a system called Strata, which is a remote steam trap monitoring and system monitoring. So if you have a meter, be it for fuel, be it for makeup water, effluent, steam, anything, we can digitize that, so you can then you can see that on your smartphone, on your HMI in an office, anywhere on site. So by monitoring those and being able to tell the inefficiencies in your returns, so how much you're putting in compared to how much you're getting out, you can also have a good indication of any losses you're receiving in your system. So Strata itself, the licensing is relatively cheap. The expensive part is the meters. And again, if you've got existing meters there, that kind of mitigates some of the cost too. So again, if this would be of interest to you, please get in touch, fill in the forms, give your details, and we can speak on the options available. I don't think you want to add anything on that as well, Anthony.
No, I think we can proceed. Thank you.
No problem. So poor heat transfer. So this, I believe, is one of the last sections. So the problems, process quality issues. So you're failing to make temperature in your process. Failure to reach required process temperature, as I just said. Process time extending. So it's taking you longer to cook your product or to sterilize your product. Yeah. So causes, it can be waterlogging. So added water in your system from failed or incorrect traps. Stool can also cause that problem. Insulating effect of scale. So if you have a buildup of scale or particulates in your pipe, that's acting as a barrier to heat transfer into your process. And wet steam as well. So it's no longer the temperature you require. The water doesn't give up its enthalpy as easy as the steam does. So you have less heat transfer. Solutions, monitor or repair or replace steam traps. Fit automatic pump traps in the case of stool. So this is particularly relevant when you have the inability to create a header pressure. So for instance, if you have a heating unit near the roof space, by creating a header by you dropping the trap close to the floor, you limit the ability of stool. This could be a heat exchanger system doing the same sort of thing. If you have no ability to do that, then adding an automatic pump unit. Improve boiler control upstream. So again, the better quality steam you produce and feed to your process, the better quality and heating times you will have. Fit, repair, replace separators. So a separator is just effectively a void space for you to enter steam in, drop any particulates or water that has been carried in that steam by hitting the internal plate and dropping down to the steam trap. And fit, repair or replace insulation. So you see less atmospheric losses. Any questions on that before I move on to water hammer?
No questions.
Okay. So water hammer. So the problem. So many of you may have heard of banging in your pipes, especially when you're starting your system. This noise can be an indication of water hammer. Vibrations of steam pipes. So the mass of the water, the volume of the water carried down the pipe creates a vibration more than what a steam system does. Damage to bracketry. So it can cause damage to bracketry. So that vibration, that noise is energy transferring to brackets, breaking them. And damage to capital equipment. So when we say capital equipment, we mean process equipment, the equipment that's probably costing you the most to repair. So causes, as you can see here. So looking at these images, I'll explain the images first. So if you have a steam light that has condensate in, as the steam passes over the surface of the condensate, there is a friction transfer that happens there, which slowly picks up speed of your condensate. Second image is kind of a middle between the slug, the water hammer you see, and the initial stages of condensate pickup. So as that friction builds up, the speed builds up, and it creates a larger wave in your system until you get to the point where you have a slug or a blockage of condensate in your steam pipe, but you have the steam behind it propelling this slug down your system. Now this can move at up to Mach 1. So if you imagine Tom Cruise in his fighter jet flying down your condensate pipe and then hitting a closed isolation valve or a trap or a control valve. Yeah, so not only would it make a mess out of Tom Cruise, it makes a mess out of your steam system. So yeah, it could be moving at Mach 1. So failure to remove condensate can be the cause of this. Insufficient fall in pipes. So a steam system should have a 1 in 100 drop. So for every 100 meters your main lines travels, it should drop by 1 meter. Of course, at some point you're going to need to raise that pipe, so you will have a riser, and on that riser you should have a steam trap to be able to remove the condensate that builds up at that low point. Waterlogging due to poor trap selection. So again, we covered that before. So if the trap is undersized or the wrong type of trap, it's not going to remove the condensate. And the use of concentric reducers. So this image here, this is the correct installation of an ecocentric reducer. So where you're going from a larger pipe to a small one. If you use a concentric reducer in this direction, you can have buildup of condensate there. If steam was coming this way, you wouldn't have the problem. But it's just where you're creating a step up, a point for condensate to build up. As we were alluded to earlier in the training, also the direction of your steam strainer. So this is the perfect position for a condensate line. So imagine this pipe is full with condensate. You have particulates that come into the strainer, drop into the strainer, and the condensate moves out. If this is on a steam line, however, you have an area where you can build up condensate, therefore build up the potential for this slug down your steam system. So in this particular case, on a steam system, on all steam systems, the strainer basket should be facing towards us. So it's on a horizontal plane, which I will cover in the next slide. So as you can see here, a steam line, horizontal plane trap, liquid condensate. So we drop it to the bottom. Solutions we can cover here, as we've alluded before, audits and monitoring of steam traps. Check the correct fall of steam pipes. So as we were saying, the 1 in 100 drop, that allows condensate to run towards a trap. Check the check strainer orientations so that you're not allowing for a buildup of condensate. Reducers, as we covered before, look, they're in the right location, the right ones are used. And auto condensate drain, so I'll cover that just in a second. And check steam startup is long enough. So when we talk about these two, we're talking about when you initially start up your system, all your dirt pockets should be open as your steam is heating. So as your system starts producing steam, starts warming up the pipes around it, you would slowly close these so that you allow the steam to build up and the condensate has been removed. So this is what we call our number 8 trap. So it's designed to be sub steam temperatures, so up to 100 degrees. You would sit this in place of your manual isolation valves on your dirt pockets, and it would open when it sees a temperature lower than 100 degrees. So this allows you to clear the condensate on a startup situation on your system, and then it will close as it starts to see steam. So by removing that condensate initially on the startup, you're allowing the steam to fill the voids, to fill the presence of your steam system faster, and you're allowing more heat transfer quicker. So delivering advantages to industry. So almost, as it says here, almost all items we encounter on a daily basis have been used as steam somewhere. So if you think about crisps, you think about Coca-Cola, in this particular case, beverages, food, even down to your car you drive and the fuel you put in it, it will have had contact with steam. So the industries that use these and the industries that can encounter the challenges we spoke about today are far and wide. So we're entering the Q&A section. I'm hoping I'm on time. I think I'm just a little bit early. Do we have any questions?
Not yet.
No, so I'll give a couple of moments for you guys to filter those questions into the chat while I move on to the next one. So how we can help you, we have a lot of literature available in PDF forms. So we have what we call our steam and condensate loop book, which we can offer as a hard copy. Of course, there's a cost there. This large book, we internally as a company refer to it as the Bible. We also have various different metric books and pullouts that we can offer you for the installation and maintenance of our equipment, the conversion of units. And it's our job to sit here and help you as best as possible. So now on your screen is our direct contact details, and please make full use of those. We love hearing from you guys, even if it's some just to supply information, to have a talk about your steam systems. So we're here for your questions. That's the whole purpose of our job. Is there any questions that have filtered through in that time where I've been babbling?
And no questions. Maybe if there's anyone who has a question.
At this stage, I don't know, Anthony, if there's anything you'd like to add as well.
Not so much. If maybe there's no other questions, then I would really thank you guys for joining us on this webinar, and I would really like and hope that you guys will fill in the form so that we can get a bit more of your contacts and can be able to share the information that you've requested. And if there is no other question, I think then we can close the webinar, and thank you all again for joining.
Thank you very much, everyone, for your time. We live for these moments, so we very much enjoy them. Please keep on participating and sending your questions through. And it's been an absolute pleasure to host and to share what little we know with you. The last bit's a joke about the little.